Hi friends, good morning. This is Reshma. I welcome you to the session of database management system. So in my previous sessions, I have discussed about the relational algebra. So the meaning of relational algebra, which are the different operations, different categories of operations in relational algebra have been discussed in previous session. So in today's session, I will just recall those top concepts and then continue with each operation. So now as we know, relational algebra is a procedural language which is used to specify basic retrieval requests in the form of relational algebra expressions. And here the operations forms, that is, if you write a sequence of relational operations which will form an relational algebra expressions. But here the order of the operations to be specified to get the required result, and here result will be in the form of a relation again. So input is a relation, output is also in the form of a relation. So as we have discussed, the relational algebra operations are categorized mainly as basic and derived operations. In basic operations, we have unary operations and binary operations. Using these basic operations, we can derive new operations like join, division, and intersection. In unary operators, we have projection, selection, and rename, which will be applied on a single relation. In binary operations, we learn union, intersection, cross product, and set difference. So now in today's session, we'll start with the unary operators. So we have three unary operators: select, project, and rename. So let's continue with select operation. Now what is the task of select operation? What is the job of select operation in relational algebra? So now we know in relational database, the data is represented in the form of a relation, that is in the form of a table. Data is stored in the form of a table which is containing rows and columns. Columns of a table indicates attributes, that is properties of an entity, and rows indicate the tuples. For example, if I have a student relation, that is a student table, columns indicates student name, student USN, semester, branch, section, marks. Then in each tuple, it gives facts of each student. For example, in the first row, if I have entered student name like Ram, is studying in 5th semester, bearing USN 1GA 19CS005 from 5th semester C section. So it will give the facts about the student Ram. Similarly, if you want to get the details about the next student, it should be specified in the second row. So like this, each row is referred to as here tuple, which gives facts about each entity. So now with the help of select operation, the select operation, it will be used to retrieve subset of the tuples or subset of rows in a table. And which row should be selected? The rows which satisfy the condition, the selection condition, the rows or the tuples which satisfies the selection condition will be retrieved with the help of select operation. And the resultant table, it will keep only those tuples that satisfies a qualifying condition. For example, from 5th semester, I want to retrieve names of only those students who belongs to C section. Then if there are 500 students in 5th semester and 150 students are in fifth semester C section. If the qualifying condition is I want to retrieve the details of the students who are in fifth semester on C section. So then it will retrieve only those students who are in fifth semester and C section. So like only 150 tuples among 500 tuples will be selected, and these 150 tuples will be in the resultant table. And now here, after applying select operation, here the table relation will be divided into two parts, and the division is done in horizontal way. So that is, it will perform horizontal partition of a table into two set of rows. The one set of rows or tuples gives the row tuples which satisfies the condition, and they should be selected, and the tuples that do not satisfy the condition are filtered out. So in horizontal partition we'll get, it will partition the tuples into two sets. In one set we'll have the tuples which satisfy the condition, and those tuples should be selected, and in second set we'll have the tuples that do not satisfy the condition and are to be filtered out. And the select operation will be denoted with the help of a symbol, that is sigma of relation R. The syntax of select operation is the symbol sigma, then selection condition, name of the relation. For example, I want to select details of the students who belongs to semester 5th and section C. Then we have to give select semester 5 from student table. Or from 5th C, I want to select means select section equal to C from student table. So like this we need to give the select operation. And the result of the select operation, as we know, it will give a new relation, new table, but that resultant table also contains same attribute as that of the original or input table. That is, number of columns in the original table and the resultant table will be same, but the number of rows in the resultant table will be less or equal to original table. So now, as we discussed, select, it will select certain rows which satisfy the condition, that is the selection condition, and the operators which we need to use in the selection condition are some comparison operators, like we can use equal, less than, greater than, less than or equal to, greater than or equal to, or not equal to. So now these operators will be used between one attribute to the another attribute, or between one attribute to some constant value. Attribute to attribute means I want to display only those students whose marks of first IA will be greater than second IA marks. So then we have to enter here in attribute 1 is marks 1, operator greater than, attribute 2 becomes marks 2. So marks 1 greater than marks 2 from student table. Similarly, comparing attribute name with the constant value means here I want to display names of those students whose marks is 98. So here marks greater than 98. So between attribute name and values. So like this we can write a select operation. So now the select operation, as we know, this is a unary operator because it works on a single relation. It should be applied on a single relation, and this select operator, it will be applied to each tuple of a relation individually. It will check the condition row by row. It will go for the first tuple, check the condition. If it satisfies, select or filter. Then go to the second row, check the condition. If it satisfies the condition, select that tuple or reject tuple. So like this, it will apply the select operation for each tuple individually. And as I already said, the degree of relation in the resulting relation will be same as degree of original. Degree means here number of columns. Number of columns in the result and original relation will be same. But the number of tuples, that is cardinality, will be less than or equal to original relation compared with the resultant. So here we'll see some of the examples on employee table. So now here I have an employee table, so which contains first name, middle initial, last name, social security number, birth date, address, sex, salary, super SSN, that is supervisor SSN, and department number. So now I want to retrieve the data from this employee table with the different selection conditions. So let's start with, assume that I want to select the employees who belongs to department number 4. So now if I see this table, so in this table, the employee Alicia, Jennifer, and then Ahmad. So these three employees belongs to department number 4. So now I want to retrieve the details of only these three employees because they belongs to department number 4. Then how to write the relational algebra expression here? We need to use select operator. Condition is department number equal to 4 from the relation employee. So then this condition will be applied to each row. First it will go for first row and check whether department number equal to 4. No, it will not select this row. Then it will go for second tuple. Check whether department number equal to 4, whether 5 equal to 4, false. Then check with department number equal third tuple. So here department number is 4. Is 4 equal to 4? Yes. So this tuple will be selected. Then it will go for the fourth tuple. The condition satisfies, so it will select. Then go to fifth tuple, sixth, seventh, and eighth tuple. So this condition will be applied to each tuple individually and select and reject the tuples which satisfies and not satisfies the conditions respectively. So now after doing executing this operation, an employee table, now resultant table will contain the three tuples. So now here if you see department number, it is 4. So number of tuples selected is 3, which is less compared to original table, but the number of columns, degree of the relation is same. It has selected all the columns. Only rows are less or equal. So now if we take another example. So here I want to select the employees whose salary is greater than 40,000. So now here, so it is greater than or equal to 40,000 I want to select here. So now greater than or equal to means again it will go to salary table. If it is 30,000 is less, 40,000 it is equal. Okay, so but now I want to, okay, so now here instead of greater than equal to, just remove this equal symbol. So according to question, we will select the employees whose salary is greater than 40,000. So second tuple, fourth tuple, and last tuple will be retrieved. So how to write the query? Select salary, use only greater than symbol, not equal to, here only greater than symbol, 40,000 from employee. So now it will select three tuples where salary is equal to 40 or greater than 40,000. So again we can see here number of tuples selection is less than or equal to the original relation, but all columns are selected. So now sometimes we need to apply more than one condition. So like want to select the employees who are in department 4 and also salary is greater than 40,000. So now we want to add two conditions. So that is whenever you try to apply two conditions on a single table at a time, then we need to take the help of Boolean operators, Boolean conditions. So as we already know about the Boolean conditions, here I will just highlight those. So first we have AND operator. So now AND after condition will be used between condition 1 and condition 2, and it will return the Boolean answer like true, false, or unknown. If condition 1 and condition 2, if both are true, it will return true, otherwise it is false. If whenever we will be using or, condition 1 or condition 2, here if both are false, then the result will be false, otherwise it will be true. If condition 1 and or condition 2 both are false, result is false, otherwise it is true. The not condition, if the condition is true, result will be false. If the condition is false, result will be true. So now we'll make use of these three logical conditions operators to apply more than one condition. Now here see, I want to apply to retrieve employees who belongs to department 4 and salary greater than 30,000. So now here, first what we have to do, we need to find the employees who belongs to department 4. So there are three employees belongs to department 4. Alicia, Jennifer and Ahmad. Now check the salary of these three employees whether it is greater than 30. Alicia's salary is 25, it is not greater than 30. So it satisfies only one condition, but and will work if it satisfies both the conditions. So this will be rejected. Then Jennifer 43,000, it is greater than 30, so select. Ahmad 25,000, but it is less than 30,000, so we need to reject. Then result will contain only one tuple. So how to write this here? Select operator. First condition, department number equal to 4, and second condition, salary greater than 30. So department number equal to 4 and salary greater than 30 from the relation. So here no need to write the table name twice. We can write only once, that is select department number equal to 4 and salary greater than 30,000 from the relation. So now what is the result now? Which contains only one employee, Jennifer, from department 4. First condition is satisfied. First condition is true and salary greater than 30, true. So both are true, it will be selected. For Alicia, true, false. So it is false. Then for Ahmad, department number 4, true, salary 25,000, it is false. So it will be rejected. So like this we can apply logical and or not on more than one condition. So now here we have one more. So where we'll make use of more than one logical operator. So now here I want to find this to display the details of employee who works in department 4 and salary greater than 25, or who work in department 5 and salary greater than 30. So now here I need to use both and or. So first we need to select department 4, Alicia, Jennifer, Ahmad, salary greater than 25. So all three will be selected. Then department 5, salary greater than 30. Department 5, I have John, Franklin, Ramesh and Joyce. From these we need to check for the salary greater than 30. So except Joyce, all other have greater than 30,000 salary. So now those satisfy the condition should be selected. So then how to write the query here? First we need to write the condition. First condition, select first department number 4 and salary greater than 25. This is the first condition. Or department number 5 and salary greater than 30,000. So both conditions will be matched. So that is true and true will be true, or true and true will be true. So here we know how or will work. If both conditions are false, then only it is false, otherwise it is true. So we can select the employee salary greater than 25 if he is from department 4. If there is no employee there, then or we can go for department 5 also. So not only one condition, if any of the condition satisfied, then only we can select the tuples. So it will select these three tuples. So now here for department 4, 443, 438, so both conditions are true, it is selected. Then for department 5, 40,000, only one employee is there with greater than 30,000, that will be selected. So now here the purpose of this query is to demonstrate use of and or operator together. So now after seeing the working of the select operation, we have found that we have observed some of the properties of the select operator, that is the resulting relation contains number of tuples which is less or equal to the original relation, like this. Result after that, after applying select operation on or, number of tuples will be less than or equal to number of tuples in the original relation. So then next, what is the minimum number of rows it can select? It can select minimum of 0 rows. Means if there is no row which satisfies the condition. For example, I want to find the employees belonging to department number 100 from the employee table. If I go and search in the employee table, there is no employee who works for department number 100. Then it will not display any row. So minimum cardinality will be 0. Then next, I want to select the employees whose salary is greater than 5,000 rupees. If I go and check the table, employee table, there all employees are getting salary which is greater than 5,000. So all rows will be selected. So minimum cardinality is 0, maximum will be equal to number of tuples in the original relation. So then another property of relational selection operation is commutative. Before going to that, here I have demonstrated the number of tuples as less than or equal to original relation. This we have done. So then next property is commutative property. So commutative property means if we change the order of execution of the condition on the relation R, first I will apply condition 2, then condition 1. So we have to take the result. Then again I will change the order. So what I will do, will execute condition 1, then condition 2. The result of these two will be same. It is just like I want to find the details of the employee who belongs to department 4 and salary is 50,000. So if I apply the condition like, first I want to extract the details of all the employees from department 4. Then from those employees, selecting only those employees who are satisfying salary greater than 50. Then I will change the order. What I will do, from the employee table, I will select all the employees whose salary is greater than 50. Then from the employees with salary greater than 50, I will be selecting only those who belongs to department number 4. So now here one and the result is one and the same. So we can say select operation is commutative. So now here department 4 and salary greater than 30. Now I have changed the order, salary greater than 30 and department 4. So answer is same. So Jennifer is the employee who belongs to department 4 and salary greater than 30. Here also employee with the salary greater than 30 and department 4 is Jennifer. So this is the commutative. So then next is cascade select operation. So now on a particular table, if I apply a selection operation n number of times, then how to represent that? For example, here we have written as relation R, select condition 1, select condition 2, select condition 3. So here I need to write select condition 1, then select condition 2, select condition 3, select condition n, like that n times applying select operation on the relation R. Instead of applying the select n operation n times, I can just take all the conditions and apply the logical operation. So now what we can do, apply selection condition only once, apply AND operation on all the condition 1 and condition 2 and condition 3 and condition 4 and, so then we can get the same result. This is just like I want to find the details of students who are in 5th semester C section from CSE from GAT. So now applying selection operation multiple times means, first I need to go for GAT, apply, select the students who belongs to GAT. First condition applied. In second condition, from those selected students, apply the condition, select the students who belongs to CSE department. Again CSE students are selected. Then again apply the condition, so that select the students who belongs to 5th semester. Selected. Again apply the condition where students belong to C section. So like this I have applied the condition separately 4 times. Instead of that, what I can do, I can apply selection condition once. So where you can write college equal to get and department equal to CS and semester equal to fifth and section equal to C. So what we have done, written all the conditions together with the help of AND. If all conditions are true, then only it will retrieve the solution. So like this, select operation can be cascaded with any number of conditions. So this is about the select operation which we can apply on the relation or of a relational algebra. So now I hope you understood the select operation with no doubts. But still, if you have any doubts, please post your questions through the comment box. And in my next session, I'm going to discuss with you the next unary operation in relational algebra, that is projection and renaming. So thank you for the current session.